In this video, I am going to introduce to you the SWHAP. SWHAP stands for Software Heritage Acquisition Process, and it's a process which has been designed to help you preserve and archive legacy source code. This process has been designed by Software Heritage and its team members and its partners. If you are already familiar with what Software Heritage is, and you've already heard a bit about the SWHAP process, and you just want a step-by-step guide regarding how to actually preserve your legacy source code, then you can directly go to the second part of this video. In the first part, I will give more of an overview of the general concepts and process behind the SWHAP. In a few words, what is Software Heritage Universal Archive? So Software Heritage is a non-profit initiative which aims at building a universal archive for source code. The way it works is that it automatically collects, preserves this public source code which is available on forges. Typically, forges are the one you can see on the right of the screen. The most well-known you might recognize are, for example, GitHub or GitLab. So Software Heritage will automatically harvest all of those forges and secure the source code into the archive. To give just some numbers, we already have more than 18 billion source files which have been archived via this process, and nearly 300 million projects which have been archived. But this only works if your source code is already available on one of those forges. If your source code is what we will call legacy, which means that it is not available on one of those archives, then it's a bit more complex. Your source code might be in the form of a paper listing, or maybe it is stored on a floppy disk, or it just lays on your personal hard drive. In that case, it's a bit more complex to make sure it is properly archived for future generation into the Software Heritage Archive. However, we do think that it's worth undergoing this process because source code has a historical value, and we believe that it's worth preserving for itself. I will just give two quick citations. The first one is from Harold Abelson, who is a computer science professor at MIT, and who says that source code or programs must be written for people to read and not only for machines to execute. And the second quote is from Len Shustek from the Computer History Museum in San Francisco, and he says that source code provides a view into the mind of the designer. These are just hints regarding why we think that preserving source code is important and is worth it. So you have a source code you want to archive, and you are not sure how to process, and this video is meant to help you do it. In very, very high level view, the process has two big steps. The first one is to properly upload your legacy source code into a forge. Typically GitHub, and in the rest of the video we will use GitHub because it's one of the most used one. Then once your code has been properly uploaded into GitHub, then we can trigger the automated archival of Software Heritage, and therefore your code will be safely secured into the Software Heritage Archive. To do so, you need some technical tools and some prerequisites. The first prerequisite is that your code should have been transposed into a machine-readable format if it was not already the case. So typically, if your code was under the form of a paper listing, then the first step will consist into transposing this code into an electronic format. Then you will need a couple of technical tools The first one is that you need a GitHub account. You will need a Linux command line console, and you will need Git installed on your computer, and you will need to connect to your GitHub account with a secure SSH key. If all of those technical elements sound scary to you and you're not sure how to get around with that, we have a step-by-step guide for the SWAP process, and there is a small section dedicating to helping you set up your working environment, and you can find more guidance here, which I will not cover in this video. But then you may ask, if the first step just consists into uploading my code into GitHub, I can just go on GitHub and do it very easily without any of those tools. Well, there is a couple of issues doing it that way, and I will give here a real-life counter example of what we think should be avoided. So here, this is a public repository of the source code of C Prolog. Prolog is a programming language which has historical interest, and the C version of the interpreter was one of the first one, built in 1982 by Fernando Pereira at the University of Edinburgh. However, the code you can see here has been uploaded by a GitHub user, whose name we can see here. And it has been uploaded 7 years ago. So if you are just someone visiting this page, you might be mistaken into believing that this code is actually much more recent than it is and has been created by this GitHub user rather than the actual historical author. Moreover, if you want to check the accuracy of the code and you want to understand where it's coming from, if where it has been found, and if we can trust the source, the only indication you know is that it has been found somewhere on the net. So you have no way of checking where it's coming from and to make sure that it's actually the historical source code you are looking for. So with the SWAP process, we will make sure you can upload your code into GitHub with the right metadata and the right information, so people won't be misled when viewing it. Before we start into the actual step-by-step detailed process, I just want to give you a brief overview of the structure that we want to achieve on GitHub. So once you will have performed the SWAP process, this is what your source code repository will look like on GitHub. So here, my source code is called My Software, and the repository is named after it. And it has 2 branches. The first branch is called Master Branch, and it contains basically all the initial material, all the information you need to understand what was the starting point of this process, what were the metadata, where is the code coming from, etc. So it has 3 main folders. The first one is called Raw Materials. So it really is meant to store all the initial documents you have about the source code you want to preserve. So typically, if you have a paper listing that you scanned, well, the scanned version will be in this raw material folder. The second folder is called Source Code, and it will contain the machine-readable version of your source code. And the third one is called Metadata, and it will contain all the metadata regarding your software. Then you have a second branch, which is called Source Code. And this branch is specifically relevant if your source code has several versions. So imagine you have 10 different versions. Maybe you don't want a future viewer to browse through every single one, but it's still interesting to understand the development history of the software. So in this branch, we will reconstruct the development history of your source code so that each version can be stacked upon each other using the commit mechanism, and it will be a very practical way to visit the source code for any future viewer. And with this introduction done, we are now ready to go into a more detailed and step-by-step explanation.